Okay, good morning or good afternoon, whenever you're watching this. We're going to talk about roles and mean value theorem. It's Unit 3, Day 2. I would like you to do this first so that we can answer some questions of what topics are covered in Unit 2. What did we cover? What questions do you have about that? And do you know what to do? Actually, I'm not sure if anything's due on Thursday, Friday. As I say that, I put that question in there and I don't think I have anything actually due Thursday, Friday. Other than study for your test. But think about those two questions, pause the video, write those questions down, write the topics that you know that are covered in Unit 2 and what questions that you have about Unit 2 so we can answer those first thing on Tuesday or Wednesday, depending on what day you have me in class. All right, here we go. We're going to talk about two theorems. The first one is called Rolle's theorem, and Rolle's theorem is really easy. Okay, here's what it says. If you have a continuous function, it has to be a continuous function. You'll notice that that is a theme that comes up a lot. That you have a continuous function. Let f be a continuous function on a closed interval from a to b, and it's differentiable on the open interval from a to b because you don't have to be differentiable at your endpoints. So let f be a continuous function on the closed interval from a to b, and a differentiable on the open interval from a to b. It says if f of a is equal to, and that should be wrong. I'm sorry. I didn't realize that I had not fixed this. I apologize. If f of a equals f of b, let's fix this. If f of a equals f of b, then there is at least one point in C between a and b such that f prime of c equals 0. Here's what I mean. Let me draw a picture because I think a picture will make more sense. Here's my picture. Here's my graph. Blah, 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 blah. I'm going to put this as A. And put this as B. What this is saying is that since f of A and f of B are the exact same number, then there is a point in there at which f prime of c equals 0. Here's the reason why, ladies and gentlemen. If you have to go from one number to another number and they have to be exactly the same, the only way for you to get there is if you go up and then down, or down and then back up. By the way, if I move A to over here, leave B where it is, and put your new A here, notice that I have A is still f of A and f of B are going to be the exact same thing still. But notice that now I'm going to have two c's for which f prime of c equals 0. Again, it doesn't tell you what they are. It just tells you that I exist. Because in order for you to go, if I have an a value of, if I have f of a and f of b being the exact same value, the only way for that to work, the only way for them to have the exact same value, change the color, is if you either went up and then came back down, or if you went down and came back up. Either way, you have a derivative that has to equal 0 because you have a point, a horizontal tangent line, right? A slope that equals 0. That's what Rolle's theorem says. So f of a has to equal f of b. So here's my first example. Verify that the function satisfies the three hypotheses and then find C. Because Rolle's just says it exists, and then you can use your information to find out what it is. Here's what I have to do first. I have to state that f of x is a continuous function. And the reason that it's a continuous function is because it's a polynomial. By definition, a polynomial is a continuous function. By definition, straight shot. So f is a continuous function. I need to figure out what f of 0 is. So that is 0 cubed minus 3 times 0 squared plus 2 times 0 plus 5. I wouldn't actually write any of that out. I would write f of 0 equals 5. And now I'm going to figure out what f of 2 is. Is 2 cubed minus 3 times 2 squared plus 2 times 2 plus 5. 8 minus 12 plus 4 plus 5. Yep, that works too. So I have proven that f of 0 equals f of 2. Therefore, you're going to have an f prime of c equaling 0. And I'm going to find that by doing the derivative. F prime of c, ooh, that's the wrong color. So f prime of c is going to be 3c squared minus 6c plus 2. And I'm going to say that that has to equal 0. And now I'm going to figure out where that's true. Well, if I think about factoring this, I have to know the factors of 6, because that's a times c, that add to be negative 6. And there are no factors of a times c that equal negative 6, but it is a quadratic, so you know what I can use? The quadratic formula. Negative b plus or minus the square root of b squared. Ugh, let me write that better. B squared minus 4 times a times c all over 2a. I'm going to move this one. So I get c, let me do a different color. C equals 6 plus or minus the square root of 36 minus 24 all over 6. So c equals 6 plus or minus the square root of 12 over 6. Let me go over here. I'm going to break it down a little bit. 12 is 2 to 2 square root, because it's 4 times 3, over 6, which then makes this one of two things. You can write it as 1 plus or minus the square root of 3 over 3. Or you can write it as 3 plus or minus the square root of 3 over 3. Don't really care which way you write it, that's up to you. What you need to recognize is that you have to make the decision, are these both in the interval? Because remember, our interval was all the way back up here. Our interval went from 0 to 2. So the question is, are both of these in there? Well, the square root of 3 is 1.7. You should know approximately what it is because it's between 1 and 2. So 3 plus 1.7 divided by 3 is still less than 2. And then 3 minus 1.7 is a positive number. So yes, they are both. Those are both the valid c values. And what that means is that at the x values of these two numbers, my graph changes direction. I don't tell you how it changes direction. I just tell you that it changes direction. All right, so let's look at our second example. Number 2 says g of x equals x to the 4th minus 8x squared plus 7. From the interval from negative 3 to 3. So g is a continuous function because it's a polynomial. I had to state that. Before you can invoke Rolle's theorem, I have to state that it's a continuous function. So now let's talk about g of negative 3. Negative 3 squared, negative 3 to the 4th minus negative 3 squared plus 7. And g of 3. I hope you guys realize I'm writing this like no math. Because I need you to recognize that these are going to be the exact same values. Because when you fourth something or square something, that does give you the exact same value because it's raising to an even power. 3 to the 4th is 81 minus 72 plus 7. So that's 88 minus 72, which is 15. Which means this also equals 15. 16, because Miss Jero can do math in her head. All I care about really is that g of negative 3 equals g of 3. I don't care what the number is. I just care that it's valid. That's all I care about. And so now I'm going to talk about what g prime of x is. G prime of x is 4x cubed minus 16x. I'm going to say that g prime of c has to equal 0. So that means that 0 is going to equal 4c cubed minus 16c. I need to solve this. They have a 4c in common. C squared minus 4. You can factor this. Or that's not plus minus 4, it's plus minus 2. Or you can solve it. I really don't care which way you solve it. But you're going to get c equaling 0, 2, and negative 2. Now the question is, are all those in my window? My window was negative 33. Yep. So there are 3 places for this graph where it changes, where f prime of c equals 0. So at x equals 0, 2, and negative 2, g of x, what this is saying is that g of x is going to have horizontal tangent lines. Or g prime of x equals 0. That's what Rolle's theorem says. Literally, that's all the Rolle's theorem says. If you can guarantee that f of a and f of b are exactly the same, then I guarantee that you have a c between a and b such that f prime of c is equal to 0. Here's my next example. It's actually technically example 3. Let f of x equal 1 over x squared. Show that f of negative 2 does equal f of 2, but why is there there is no number c such that f prime of c equals 0? So let's figure this out. And why does that not contradict? So f of negative 2 is 1 over negative 2 squared, which is 1/4. F of 2 is 1 over 2 squared, which is 1/4. So there's my f of negative 2 equaling f of 2. That's good. And then we're going to do f prime of x. By the way, f of x equals x to the negative 2. So f prime of x is negative 2x to negative 3, or negative 2 over x cubed. And ladies and gentlemen, if you did not know that there's no way for me to have negative 2 over c cubed equaling 0. Never, because the top would have to equal 0. So that doesn't work. But f of negative 2 equals f of 2, so it should say f prime of c equals 0. Why does it not contradict? Why does this not contradict Rolle's theorem? And hopefully you have recognized, because I didn't write the very first statement. And the very first statement says that I am a continuous function over this given interval between negative 2 and 2. I am not a continuous function. F is not continuous from negative 2 to 2. Therefore, Rolle's doesn't apply. If your function is not continuous, you cannot apply Rolle's, period. That's why it doesn't contradict Rolle's, because it's not a continuous function. And literally, if you could do this first statement, you don't have to do any of the rest, right? This purple statement. Purple statement would be the very first statement I would make, and then I don't have to do the rest. Now, it said show that, so that's why I had to do all the rest to start with. But you can't use Rolle's because it's not a continuous function. All right, here we go. Here's what the mean value theorem says. That's the other theorem. So mean value theorem is like the general all-encompassing. Rolle's is a subsidiary or a subset of mean value theorem, but mean value theorem is the over-encompassing. It's just, I think it's easier to start with Rolle's. And here's what mean value theorem says, otherwise known as MVT. By the way, we will abbreviate mean value theorem as MVT, as is the entire calculus community. Let f be a continuous function on the closed interval from a to b. Again, that notice it's continuous and differentiable on the open interval from a to b. There is at least one point in C such that f prime of c equals f of a, b minus f of a over b minus a. In other words, ladies and gentlemen, that the slope of the secant line must equal the slope of the tangent line, or the instantaneous rate of change is equal to the average rate of change. That's literally what I'm saying. Slope of the secant line, because notice that this is the slope of the secant line. This is the slope of the tangent line. So you have a point in which the slope of the secant line equals the slope of the tangent line. So a picture. Blah, blah, blah. Blah, blah, blah. If I have the point, let's go this way. Here's A, here's B. If you're talking about a tangent line or a secant line, there's my secant line. At some point in here, somewhere, there is a C, green, that has the exact same line, same slope, which means I have parallel lines. Secant line is going to be parallel to the tangent line because I have the same slope. And the question is, where is that C? I can guarantee that it's there. I just can't guarantee what it is. I can guarantee that it's there. That's what mean value theorem says. Mean value theorem says that if my average rate of change is equal to my instantaneous rate of change, then I can find, then there is a C that occurs inside A and B. Hey, by the way, why is Rolle's theorem a subsidiary of this, ladies and gentlemen? If f of A is equal to f of B, if these two are the same, then when you subtract them, you get out 0, and therefore f prime of C would equal 0. That's why Rolle's is a subsidiary. So you could always use mean value theorem instead of Rolle's. That's totally fine. You know, because it's a subsidiary. So mean value theorem, if you're like, oh, I don't want to memorize both of them, you can just memorize mean value theorem. Or you need to know what Rolle's is, because sometimes I'll ask what is Rolle's, or use Rolle's, but if I don't say it, you can use mean value theorem. So first of all, tell me that this is f is a continuous function. Oh, I forgot to say differentiable. It's continuous and differentiable because of poly. It's continuous and differentiable, and actually, as I say that, for Rolle's theorem, I did not say that it was continuous and differentiable. I just said it was continuous. So I need to put and differentiable. I apologize. I should have said continuous and differentiable, because both of them have to be met. Continuous and differentiable. Has to be continuous and differentiable. A polynomial is continuous and differentiable. The reason that I need to say that is because an absolute value is not differentiable. So that's the issue. I apologize. It's a continuous function, but it's not differentiable at certain points. So if f is continuous and differentiable because it's a polynomial function, I'm going to do f of -1 and f of 1. F of -1 is 3 times -1 squared plus 2 times -1 plus 5. That's 3 minus 2 is 1 plus 5 is 6. F of 1 is 3 plus 2 plus 5 is 10. And then I'm going to find f prime of C, just 6x plus 2. And the reason that I did that is because we know f of, that's the wrong color. Because the formula says f prime of C equals f of B minus f of A over B minus A. F prime of C is 6x plus 2, 6c plus 2. That should be f of x. 6c plus 2. This is going to be f of 1 minus f of -1 over 1 minus -1. Or 6c plus 2, f of 1 was 10 minus 6 over 2. 10 minus 6 is 4. 4 over 2 is 2. So 6c equals 0, or c equals 0. Yes, 0 is between -1 and 1. So we're good to go. That's where it's going to have the same slope as between -1 and 1. That's what I'm saying. That my derivative at 0, the slope is exactly the same as the slope of the secant line between -1 and 1. Here's my next example. It says g of x equals x cubed minus 8x squared. G of negative 2 equals, before I do that, let me state g is continuous and differentiable because it's a polynomial. Now let's do g of negative 2. Negative 2 cubed minus 8 times negative 2 squared. That is negative 8 minus 32, which is negative 40. G of 5 is 5 cubed minus 8 times 5 squared. That is 125 minus 200, which is negative 75. So now let's talk about g prime of x. 3x squared minus 16x. And now I'm going to talk about the formula. It says g prime of c has to equal g of b minus g of a over b minus a. And again, I have negative 2 and 5. So g prime of c is going to be 3c squared minus 16c. And this is going to be g of 5 minus g of negative 2 over 5 minus negative 2. Three c squared minus 16c, g of 5. What did we just say it was? G of 5 was negative 75. Negative 75 minus negative 40 over 7. 3c squared minus 16c plus 40 is negative 35 over 7, which makes this equals 3c squared minus 16c equals negative 5, or 3c squared minus 16c plus 5 equals 0. I'm looking for the factors of 15 that add to be negative 16. That'd be negative 15 and negative 1. So 3c squared minus 15c minus 1c plus 5. I'm doing factor by grouping. You remember, factor by grouping. These two have in common a 3c, and then I have c minus 5. These two have in common a negative 1. And the reason I'm pulling out a negative 1 is I need my two parentheses to match. Now my two parentheses match, and I'm literally factoring out my two parentheses, c minus 5 and 3c minus 1. I don't care how you factor. You use box. I use box also. Slide and divide I would not use, just an FYI, but anything else I don't care. You can, as long as you're showing your work, you can factor however you want. C equals 5 and 1/3. Let's make sure that those are in my given interval, and they are. Well, one is an endpoint, that's okay. They just have to be in my given interval, and they both are. So we're good to go there. All right, I think I have one more. Do I have one more? I do. Actually, I'm going to skip. I'm going to skip to this one, and then I'll go back to that one in a second. This is number 6. And here's why I want to skip to this, because I need you to recognize what conditions have to be met first. That says do not satisfy. So think about what it has to be in order to be satisfied. It has to be continuous and differentiable. Well, this one's a continuous function, so that's good. This is a continuous function, so that's good. This is not continuous, because x can't, but it is. But x can't equal 3, so not continuous over its domain, but yes for the interval. So it's good for the interval, so that's really the thing to think about. And then this one is continuous. In this given interval, I can do negative 1 to 1. So I'm continuous. Let's talk about derivatives. The derivative of this, by the way, is 1/5 x to the negative 4/5, or 1 over 5 x to the 4/5. Ladies and gentlemen, this is not differentiable at x equals 0. That is in the interval, so this one does not satisfy the conditions. It means you cannot, excuse me, it means you cannot use MVT. No MVT. Which one does not satisfy? That one doesn't satisfy. Let's talk about, I'm going to, just because I'm on the track of doing derivatives of fraction of radicals, 1/2, x plus 1 to the negative 1/2, and then times 1 because it's chain rule, which makes us 1/2, the square root of x plus 1. When you plug in -1 into this, it is not differentiable, but that's okay because it has to be differentiable on the open interval. -1 doesn't work, but I don't have to be differentiable at the endpoint. So, yes, this satisfies. So, might as well do this one because we're here. So, f prime of x equals, this is quotient rule. So, low d high minus high d low all over low. The x's are canceling out. I'm left with -3 over x minus 3 quantity squared. That is a continuous function. That is differentiable between -1 and 1. So yes. Yes to MVT. And this one is going to be product rule. G prime of x equals the first times the derivative of the second. X squared minus 1. No, 1 minus x squared. I did it backwards. Plus the second times the derivative of the first. Think about the arc cosine of x. For what angle does cosine equal 1 or equal -1? And the answer is I can get both of those out. It goes from 0 to pi, by the way. That would be what your y values will give you out for arc cosine. And again, this is okay. And the reason that this one is okay, because again, I'm differentiable on the open interval, not the closed interval. So even though I undefined at 1 and -1, that doesn't matter because that is part of the, that is the open interval. I need to be on the closed interval, or that those are closed and then the open. So this one's good also. So the one that actually does not work is A. Think about that. Okay, I'm going to go back and I'm going to talk about this one real quick. If it has exactly one real root, that means it had to cross the x-axis. And if that's true, I'm going to use a mean value theorem to help me out there. Because if I can prove, well, I'll show you. So f of -2. F of -2 is -2 to the 5th plus 10 times -2 plus 3. -32 minus 20 plus 3. -52, so -49. Is that what I want to do? Michelle has to think for a second. Yes, okay, so, and then I'm going to do f of 2 to the 5th minus 10 times 2 plus 3 to the 5th of 32 plus 20 plus 3 is 52, 55. Oh, I should state f of x is continuous and differentiable. Okay. If I want to do, that should say exactly one real root. So here's the deal, ladies and gentlemen. I know that I have to cross the x-axis between 1 and 2, or between -2 and 2. I know that because of IVT. To get from negative 45 to 55, I have to cross the x-axis. That's right there. Now, so by IVT, I know that I'm going to cross. Question is, do I cross more than once? And I can figure that out by talking about the derivative, because I can talk about how it turns and all those pieces. So let's talk about f prime of x. And now let's talk about f prime of c. So 5c to the fourth plus 10 has to equal 55 minus negative 49 all over 2 minus negative 2. So I have 5c to the fourth plus 10. 55 and 49 make 104 over 4, which makes this, I'm just going to go over here, 5 to the fourth plus 10 over, it goes into this twice, 24 is 6, so 5c to the fourth equals 16, c to the fourth equals 16 over 5. Let me just make sure my math is correct. Yeah. So c equals plus or minus the fourth root of 16 over 5. That means that I feel like it. And so c is going to be plus or minus 2 the fourth root of 5. And so it's got it has it's two places where it has the same rate of change. But that doesn't necessarily, I did this, but I don't think I set it up the way I wanted to. So I will fix this next class, because that doesn't prove necessarily that it has the exactly one row root. The IVT is better off for that than the other piece. We'll talk about that next class, because I want to do that. We're going to talk about this. A car traveling in the highway passes mile marker 147, traveling at a speed of 60 miles per hour. 5 minutes later, the car passes mile marker 154, traveling 65. Proves that the car must have exceeded the speed limit of 65 miles per hour at some time during the 5 minutes. So here's what we need to know. Let's talk about the, it's a speed of a car. So since the speed, we're talking about the car, so the car, the speed, I should say, is a continuous differentiable function because of the way it works. So let's talk about a rate of change. 60 miles per hour. So let me back up. At mile marker 147, I'm at 60 mph. At 154, I'm at 65 mph, and I am 5 minutes later. So let's talk about the average rate of change. And these are not the order pairs, by the way, because I set that up wrong. It would be at time 0, I'm at 147, and at time 5, I'm at 154. There's the actual order pairs. So the average rate of change, the AROC, is 154 minus 147 over 5 minus 0. By the way, this is why this is miles and this is time, and this is minutes. So this is 8 over 5. This is miles per minute. The problem is I need miles per hour because I have to have my speed is miles per hour. So this is an issue because I had to have miles per hour and not miles per minute. So I'm actually going to go back and fix something because I don't want miles per minute. That's an issue. I want miles per hour, which means this needs to change. 0, 0, whether it's 0. So 5 minutes is how many of, it's 5 minutes out of 60 minutes, or it's 1/12 of an hour. So it's 1/12 right here, which makes this 1/12, and now it's hours, and it's hours, because I needed hours. Miles per hour, so I had to do, so this is 8 times 12, which is 72 miles per hour. So, ladies and gentlemen, we had to prove at some point you've been bigger than the speed limit. The speed limit was 65. The average rate of change is 72, which is greater than the speed limit, which would be the instantaneous rate of change. So, yes, you went over the speed limit. We'll talk about the rest of this in class. Have a great day.